Thanks for coming. My name's Derek Thurston. I'm a solutions architect at Red Hat, and today I'm going to talk about data analytics for decision dominance at the edge. So the agenda is going to be talking about the challenge that we're facing, the edge constraints that we have to work with, how AI/ML at the edge can operate, and then talk about our solution for that. So I'm going to read the problem statement. I've sort of summarized what was in the original call for papers. How can Red Hat enable the Army to meet mission needs through advanced AI/ML capabilities at the edge, ensuring real-time decision-making, operational resilience, and resource optimization? So the first thing with all this data is how do we make it more relevant for commanders out in the field? The better data that we have allows for better decision making. This goes into the 5 V's as well for volume, velocity, variety, veracity, and value. And what we want to do is reduce the volume and variety being sent back. We want more useful data to be sent back. And all these environments, when we're talking about edge, they are in DDIL situations for the most part, denied, disrupted, intermittent, and limited bandwidth. So at the edge, obviously we can't run a full ML ops pipeline in those environments. There's lots of standards for in small form factor devices, and so what we need to do on a reduced compute form factor is look at packaging your models into a container and deploying them through whatever means necessary. So that means data center will probably have to do your model training, and then that's going to have to be shipped out to the edge in a smaller form factor, which would be a container in this case. But there is no right answer on how to do this necessarily. It's a way to, this is one of the ways that we think is a good way to do this. So some considerations for edge deployment. What are your hardware and software constraints that you're dealing with? How big is your edge device? Do you have a 4-node server? Do you have a NUC or something even smaller? How are you going to do lifecycle management with this? Do you have a plan for hardware? Do you have a plan for infrastructure setup, updates? And then also, how are you going to manage all this? How are you going to push software updates? How are you going to push containers out to the edge? All these things need to be thought about before setting any of this up. So the first thing we need to do with edge computing is we're trying to derive the most efficient use of data and capture opportunities from it. So filtering our data at the edge using AML is a way to get rid of some of the waste and ship all the bits that we actually want to see to people who make decisions. Customer experience, that sounds like maybe a Walmart thing, but really it's not. It's the commanders who have to make decisions, their customer experience, getting the data and the processing closer to them to get the job done, that's important. Placing the computer services closer to their locations. And sometimes this might be a UAV or a vehicle. There's really no predefined way to do this. So latency sensitive applications as well. Getting closer to your customer is very important. Reduce latency, reduces the decision loop. And again, containerizing all these things makes it easy. It's a possibility. Don't necessarily have to go with containers, but I mean, containers are pretty small. So Red Hat's solution for this, we have a product called Red Hat Device Edge. And what Device Edge is actually 3 products. in one. It includes our standard operating system, RHEL, Red Hat Enterprise Linux. It also includes our build of MicroShift, which is a Kubernetes API-compatible distribution that runs on a single node. And it acts just like Kubernetes. It's just a small version of it. So you can do it on like a single socket system with minimal memory, minimal storage. So perfect for edge stuff. And the last thing, Ansible for automation. So deploying models and everything, that doesn't necessarily have to happen in the Ansible, but updates and patches and making sure your system doesn't go down. And like there's a plan for when it does go down that it comes back up the way you want it to. That's where Ansible would come in. Additionally, we have a real-time OS kernel. So if determinism is something you're looking for in a response to sorting through data, then we can absolutely, we have a kernel for that you can put in. And because all our userland tools are exactly the same for our real-time setup versus our non-real-time setup, you have access to our Podman, which is our container tool. All these things, they'll run on this kernel. So completely supported by us as well. The graph on the right is showing a real-time kernel versus the green is a real-time response, and the blue is a non-real-time response. So again, real-time processing and management. Device edge. This will allow the burden to be reduced on whoever's trying to access this data. We don't need to have all the data shipped back to be processed and looked at. We want to send the correct data back. And again, that's through the models. So I'm going to skip to some diagrams here. One last thing too. Security-wise, we have all the certifications, FIPS 140-2, 140-3, common criteria. We work directly with DISA to do our STIG. So all those things are already there. All of them can be Ansibleized as well, so automated. So you can stand a box up from bare metal. It'll apply the STIG for you. You can custom tailor that. All that can happen in one-touch deployment. We can also do that with our MicroShift and our OpenShift products, which is the larger version of Kubernetes. So this is my very simplistic diagram on us getting data from point A to point B, or point A, B, C, D to E, I guess. Traditionally, like large pools of data exist. From a security perspective, not necessarily the best idea, because now you have everything in one big pile. So the solution would be to start running AIML at the edge to sort the data out, drop everything you don't need, the stuff you are looking for, you ship back. Now you have a smaller pool of data to operate on. And immediately this begs a question like, well, what about the DDIL part? DDIL, right? So this is the processing part, I'm sorry. So the DDIL portion, so jamming, lack of transport, denied disruptant, intermittent and limited connectivity, all those things happen. All our tooling that we have currently for our operating system runs in these environments on these nodes. So sort your data using AIML, it can be completely disconnected. And then from there, we have tools, AMQ queues, which is a way to store data and wait for connectivity. Also share data between data points. Like there's no reason why planes, UAVs, whatever is nearby can actually push data to each other, and whoever's got the best transport can use it. So all those things are done today across commercial and DoD systems. We also have device edge in space too, so I mean that's probably the most distant location we could work from. That's it. That's my quick shotgun RHEL for device edge talk. I'd love to get any questions anyone has. Yes, sir. So the question was, what's the effectiveness of being able to winnow down the data and get what's most important. We provide all the tools for that. That's up to you all, how you train your models. So it's completely outside of our purview. We don't have models. We have all the tools to do that part. We have ML ops pipelines and DevSecOps pipelines, but yeah, so train. Any other questions? If anyone has further questions, we're at booth 503, 305. Sorry. There's our booth mom there. Come by. We have OpenShift, single touch, push button deployment of OpenShift environment. Literally one touch, and we have the most radical setup ever. We have Microsoft Server running MySQL, talking to containers, so it's pretty epic. Anyway, appreciate everyone's time. Appreciate FCA. Oh, yeah. And we have Keycloak as well. All right, thank you all.